morning. So this stream here is going to be me continuing to work on my project. Here's where we left off yesterday. Um, Let me go, gonna break this out so we don't lose the chat. Okay, so now I'm just gonna rearrange everything real quick. Um, Here's the GitHub for the project. You could go here and get the data. I guess it's here. I should update it. There's the guy who commented yesterday asking if he could get the data. I hope you got the data if that was you commenting that. Okay, good connection. I've got a Trello board. We could close out of that because we don't need it. Here's our code, our terminal window. These are some plots I have up. I'll explain those in a sec. We don't need Excel and we want this. So, previously let's go up here. I'm going to talk about what I have so far. So I noticed I scraped the data from a website, this website right here. This is the web archive because the site isn't up anymore. This isn't really interesting. Let's go back. But basically, they had all the data on the site. I scraped it all into this data folder, and then I put it all into this Excel file. We can see the Excel file here. Go up a few directories. So this is what the data looks like that we have. And the years go from 2007 through 2021. And we have, let's just wrap this around. Oh, okay, we need to edit. And wrap text. Okay, so we have for each game we have information to identify the game, like home team, away team, the date the game took place, year and week. And then we have home score, away score, and then we have opening and closing spreads, totals, and money lines for each team. Now I took this data and I plotted it here. On the y-axis is the swing in the money line for the home team, and the x-axis is the swing in the money line for the away team. I plotted it here. Now you would expect that if however much a game swings in favor of the home team, it should swing an equal and opposite amount in favor of the away team. So I've modeled that relationship that I predicted it should have here with just y equals negative x line. So negative relationship between the two. I noticed some things in this trend. First is that it follows the trend I expect it to. Second is that there are these outlying data, I don't know what to call them, lines, I guess. They seem to follow that slope, y equals negative x, but they seem to have a different y-intercept. They're offset above or below the line. And then I noticed a third trend, which is that this data down here tends to be blue. If we select this region, it's all blue, so all wins for the home team. If we select this region, it's almost all wins for the home team. So this made me think that we could find a region in our plot and then take bets based off of that region. So the next thing to do was automate that. So I wrote some code that says, okay, get these different regions. This is the first technique I used, the triangle technique. And I wrote some code that said, let's get these different regions. And then whatever the region is, return what the profit is from taking every bet in that region. So this kind of shows that that works. And then if we optimize for a region, we get that. That looks pretty good. But if we optimize for all previous years and then test it on subsequent years, this is the profit that we return. And so we see that oh, that's percent return. Well, did I delete the other? Okay, so this is the first results I got. And so we see it's negative for 3 years. Sorry, this is the first one. So actually, this was negative for 5 years. This one was negative for 4 years. Um, I then changed the output, so instead of optimizing for profit, it's optimizing for percent return, um, which is this one I showed right here. Um, Now, when we optimize, this is the wrong thing. Um, Sorry. When we optimize for percent return, this is the result I get. I forgot how many years that's training on. So then that made me think, okay, well, what if we optimize for percent return? Let's do the analysis. I wrote an analysis that goes back and looks at how many years do we want to use for training data and tries to optimize that. So um, when I go through and look at different years to use for training data, this is the result I get. And it's interesting that training on 7 years of data um, returns no negative values. I'm trying to find, I put that into the code somewhere, but I might not have saved it. So, okay. Um, all right, so this is testing how many seasons to look back with the triangle method. And we noticed that 7 seasons doesn't return negative values once. So I've been messing around with the code up here. So we're going to want to change our region assessment. Let's see, what are we doing here? We're returning percent return. So I've just been messing around with this. I'm going to put that back to there. And then we're going to turn on our optimization test. Nope, don't want optimization test. We want to do the optimization analysis. And then here, years to test. So I'll just overwrite that. Years to test is equal to a list with only, oh, I take that back. So we're going to test all years from 2010 to 2022, but the num years to train on is 7. Okay, and then let's run that. I'll just demonstrate that that doesn't return negative. This is differential evolution, so there's some randomness mixed into this optimization. So it might return positive, but when I ran it here, uh, it was positive for every year. Actually, I take it back. We could go find it here in optimization data, group optimizations. Nope. Training years test. Um, we tested the triangle method, and on 7 years of training data, here are the results. So we could see that it's not negative once. Now let's go put that in the PowerPoint so we don't lose it. Okay, so now that looks like it's a good trend, but here's the problem. It looks like a good trend. Um, okay, triangle method training on 7 years returns positive for all years. And here it is. Triangle method training on 7 years and percent returns and percent returns. Don't want to say returns twice, so we'll just say yields positive for all years. Okay, let's make sure, I want to make sure the stream's called the right thing. 12:15, yep, that's today. Now it says that Oh man, the bit rate is low. Why? It's the most frustrating thing in the world. Low bit rate, even though I pay $110 for internet. Okay, so there are the results from doing all years. Now, so that's the analysis. Now, what I was going to say is this looks pretty good, but we're gonna want something stronger than 7, because what this does, basically for any amount of years we train on, 1 through 10 years, other than 7, it goes negative at some point. So that says it's not a good trend. And at 7, it never goes negative and it doesn't take any bets in 2020. So it's just that the problem is this isn't a really strong trend. This is good. We're getting close to a good strategy, but we're going to need to optimize a little bit more. Um, okay, so that takes us to where we were at yesterday. Now let's go to the Trello board. We're going to want to, um, this is what we're working on. So we want to repeat analysis for all region types. Um, okay, and then we want to automate the analysis plot. So get analysis, let's make a function called get analysis plot. Um, all right, so get analysis plot of analysis folder. Gets plot for the years, test training years for the test training years analysis. Um, okay. Uh, Now we're going to add a test for that. And then I'm going to go to the bathroom real quick. So test training years plot is equal to 1. Take off this one. And then we're going to say get analysis plot. Oops. Not analysis. We're going to call this get training years plot and then pass in the folder. Okay. Then I got to go to the bathroom and I'll be right back. Just going to bring up the notepad real quick. BRB. Okay, cool. And I'll be right back. All right. Now it's time to write the code to automate the plots. Um, so get training years plot. Now let's see if we still have the commands up in Python. Optimization data. Might not have it up still. For C item and enumerate A. Yeah, I'm not seeing it. So we're gonna have to write it again. So let's go down here and we'll just put in pandas. Gonna build it here in the terminal. Okay, so let's make this bigger. Don't want to miss any chats. Now file is equal to pd dot import os dot lister of optimization data. Then we're gonna go that slash training years test. Training years test. Hybrid triangle. So let's go to triangle. Oops. Slash triangle. Okay, then we get a directory for each year. So, folder path is equal to optimization data slash training years slash triangle. Okay. Put this over to the side. Now let's say, all right, so analysis folder by default is optimization data slash training years slash triangle. Okay, now for year in os.listdir of analysis folder. All right, so we're gonna say, let's get each year in the analysis folder. Now, inside of that, what's it look like? So now we got the year, so now we're gonna say, um, sub, so we're just gonna wanna skip to the next subfolder. Subfolder is equal to os.listdir of function string, and it's going to be analysis folder slash year, because that's the year folder. Um, okay, so then we're going to want to list each item in there. I for I in. So we're going to get each item in there and then get the 0th item because that should just be, there should just be one subfolder. Now back into here. So then we click on the year subfolder and then there will be a 0 subfolder. So now next subfolder is equal to I for I in os dot list dir a function string, and then this directory is analysis folder slash year slash subfolder. Okay, and then that gets us the next subfolder, which should just be 0. Get the 0th item of it. And then when we go in there, then we get a folder for each year. So then we have results. Next subfolder. Okay, now results is equal to pd.read csv of, and basically we have this whole thing, and then we're going to add slash next slash next subfolder, and then we're going to do slash results dot csv. Okay, and then let's just say print, just to make sure we're getting the results. And then we want to say year and then backslash n and then results and then year and then backslash n, then results and then backslash n and then 1, 2, 3, 4, 5 and one more. Okay, now let's go look at what that looks like when you run it. So get training years plot. If self dot get training years, if test training years plot is equal to true, then we say get training years plot. Okay, now let's exit out of here. Let's run the file. No such file or directory. Optimization data training years triangle. Oh, training years test. Training years test slash triangle. Cool. Okay, so now we're printing for each year. Now we could say for year in, get the results. Now, um, for year in each year, results is equal to that. Then we're gonna say plt dot. Okay, so first let's make a figure. Fig equals plt dot figure, and don't know what to make the fig size. Um, Now for each year, okay, so ax1 equals fig dot add subplot. Um, and we want the one subplot to, let's see, how could we make a subplot take up multiple columns? How to make a subplot take up multiple columns. Um, so I want it to look like this because this um, over here is the one that we care more about seeing. Like this should take up most of the space. This should just take up a little of the space. So this should take up 2/3 of the space or so. It could even take up 3/4. Let's just make it take up 3/4 of the space. So AX1, so, oh, but how would we make it take up 3/4 of the space? Um, nice. I want something like this. plt.gridspec 44. That doesn't help. So 2 rows and 3 columns for the grid. Okay, let's try doing that. So I'm gonna put this over here. Okay. I'm just gonna try that in here actually. Okay. Now from matplotlib import pyplot as plt. Then we can say plt.plot. Nope. plt.grid is equal to plt.grid spec 2 rows, 3 columns. So we just want 1 row, 3 columns, W space. White space doesn't matter. Okay, from this syntax we can specify subplot locations. Alright, let's do that. Now we're just going to say plt dot subplot grid, and the first thing, so we're going to say x1 is equal to plt dot subplot of grid, and then 0, 0. So this should be 0, and then 1 till. and then AX2 is equal to plt.subplot of grid of 0, 0. Hi. Ooh. Okay. Um, so now we can say ax1 dot title is, or set title. So we're going to set the title to be um, big grid. And then ax2, the title is going to be little guy. And then let's show that. Nice. Cool. Um, so let's say grid is equal to plt.grid spec, and we want one row, 4 columns. And then um, so then we could just say line axis is equal to plt.subplot of grid, and we want to get the 0th row and then all columns except the first one. And then we're gonna say the histogram axis is equal to plt.subplot of grid of 0, 0. Okay, so then for each year in years, line axis dot plot um, line axis dot plot so results dot um results dot year, and then results dot percent return, and then the label is equal to um, f string of year years. Okay, now histogram. What was the histogram? I think just, oh, it's not a histogram, it's a bar plot. Matplotlib bar plot. Okay, so then let's just try to manually add the bar plot. So, get rid of that. Okay, so if we want to add it for each year, let's say, now this is the bar axis, and then down here we say bar axis dot bar, and then x. So x should just be the years to look back, and then y should be the average percent return. average returns is equal to year, and then years to look back is equal to also empty list. Then for each loop, we say average returns dot append. So we want to add on to the end of average returns results dot percent return dot mean, and then years to look back dot append results. No, this is just year that we're appending, and then after the loop, we're gonna say bar axis dot bar years to look back, average returns, and then we're gonna say line axis dot x label is year, line axis dot y label is percent return, and then these have to be set x label and set y label for it to work on an axis. Set y label, set x label. Um, Now we want to set the title. So that title of the bar plot will be average percent return average percent return, and then bar axis dot x label is num years to train on, and then we're gonna make the title the whole thing. Do plot dot subtitle, testing number of training years, and then we're gonna make a grape, or is it frozen? Interesting. Mm, yum. Thanks. All right. plt.tight layout, and then finally we want to show it. So let's exit out of there and run the file. Subplot has no, oh, set X label. Okay, now this should work. Let's see what that does. Nice. It's not exactly what we want. plt.grid spec. That would look better. What do we call this plot? Average percent return. I mean, we could just make that title, put testing number of training years as the title for the second plot. I guess the second plot title could just be performance. Line axis dot set title dot set title performance over time. Um, and then how do we specify the, so we could say, man, matplotlib specify dimensions. But I don't want to make, oh, I guess I need to do figure. So what if we just say fig is equal to that? How to add a grid spec to a figure. How to add a grid spec to a figure MPL. Okay, so we want to, the problem, I know how to do the grid spec, but I don't know how to change the sizes. Um, okay, so we can pass in the figure. So let's say fig is equal to plot dot figure. And then in grid spec, when we're passing n rows, n calls, and then we're gonna say figure is equal to fig. Um, Now this is fig dot add subplot, and then same thing here, fig dot add subplot. Um, do we need to put the figure in anywhere else? Here. These should be fig instead of plot. And this one we meant to change to bar, or meant to leave as bar, not change to fig. Um, Now this should work. Oh yeah, we want to do the fig size is equal to um 10 by 5, 12 uh 12 wide by 9 across. Let's try that. All right, now let's run it again. Unexpected keyword figure V. Oh, okay, fixed that. No plot. Fig dot show grid. Oh, plt dot grid spec. Grid layout to place subplots within a figure. Fig dot add subplot. Huh. We're gonna have to look at some examples. Um, Fig equals that. Fig dot add axes. Fig xd plt dot subplot mosaic. Upper left, right, lower left, right. Ah, okay. This is what we want. So subplot mosaic. That's just such a nightmare. I don't want to deal with any of that stuff. Subplot mosaic. Maybe I do. Okay, this is what I'm trying to do. Fig equals plt dot figure. All right, now let's put these next to each other. Fig equals plt dot figure. We give the fig size. It didn't specify a layout. Grid equals, oh, So we want to do fig.add grid spec, not grid spec. So fig.add grid spec, and then we probably don't have to specify this in here. Now if we try to run this again, will it work? Nope. Okay. So fig.add spec equals fig.add. Now ax0 equals fig.add subplot. Yeah, this seems like it's doing the right thing. Add grid spec. Fig.show. Maybe we need to do plot.show instead of fig.show. I don't think that's what the problem is. But let's go see. Oh, yeah. Okay, that takes care of our problem for us. So, that looks okay, but 12 by 9, that's like a square grid. Why is 12 by 9 returning a square grid? Let's just do 10 by 5. Oops. 10 by 5, save it, F11. Okay. Now, is that going to give us the right dimensions? Is the big question. Let's run it again and look at the dimensions. That is close to, I mean, that looks about good for me. Um, the only weird thing now is this is different results from yesterday. I just realized. Oh, because it doesn't put numbers to train on in order. And we need to add the legend in that top plot. Oh, and the V line. So line axis dot ax h line at 0. Okay, so now we have the horizontal line at 0. Now our big question is why. Okay, that got numbers to train on got all messed up. So how do we put that in order? Average returns, gonna make that a dictionary. Then we're gonna say years to look back. So average returns of year is equal to that. Then take off the end parentheses. We don't need this anymore because we're gonna define years to look back later. So now let's say years, don't want that cap. Years to look back is equal to, we can do list comprehension and we can do year for year in average returns dot keys. And then the last thing we wanted to do was show the legend. Bar axis, line axis, line axis dot legend. Axis dot legend. Okay. So now let's get out of there and go try to make the plot again. Update unhashable type dict. Average returns of year, years to look back, year for year in average returns dot keys. what line is that error coming from? Um, inner, oh, years to look back. Average returns, 433 and get training years. So it's the problem is when we're calling year to look back. Year for year in average returns dot keys. All right, let's just put the debugger in here because it says there's something wrong with that list comprehension, but I can't figure out what is wrong with it. Um, average returns. Um, so let's just try doing this. Year for year in average returns dot keys. Now, why wouldn't that work? Um, okay, order a dictionary. Python, order a dictionary in order of ascending keys. Sort a dictionary by key. Even if you sorted the key value pairs, you wouldn't be able to store them in a dict in a way that would preserve ordering. Order dict. Oh. OD is printed out. For Python 3 users, one needs to use the dot items instead of dot iter items. Huh. Oh, sorted of d dot items. So let's say uh average. Can we do, so let's say average returns looks like that. So if we do sorted of average returns, um okay, so how to write over keys of dictionary. Python write over the keys of a dictionary. So we want to figure out how to we write over the keys. Right now they're strings, but we want them to be integers. Um, understanding how to iterate. I mean, I know how to do that. Um, the real problem is that the years aren't in order here. Average returns of year. Okay, so let's say for year in average returns dot keys. So we're going to look through the dictionary. Now we're going to say key. Well, we already have it. So we have year is whatever the key is in average returns. Now year is equal to int of year. So just basically make it an integer. Now, do we want to look through every year? Basically, we want to get the years to be in order and then get the average returns of the year to be in order. So for year in average returns dot keys, year equals year. So then we're gonna say we're gonna make ordered years is equal to this. Year is equal to int year. How do we order a list? Python put a list in order. Sort. So let's go in here, and does sort do anything for us? So we're gonna say sort, and we want to make a list, and we want to say int of I for I in average returns dot keys. So this should return the sorted number of years to look back. Need to import it from somewhere? Oh, dot sort. So just get the list, and then at the end of it, throw on dot sort. Okay. Now what does that look like? Int I for I, average returns dot keys. Okay. Then I for I and average returns dot keys. For I in average returns dot keys. Now int of I for I, and then dot sort. Why doesn't that do anything? So we have to figure out how this works. Prime numbers dot sort. Oh, we need to print. But that won't help us at all if we have to store it in a variable, because this doesn't let us store it in a variable. So that's not sorting. Sort parameters. Sort a given list. Well, that's just confusing. So maybe we need to give this a name. So we're going to say A equals that, A dot sort, and then A, okay. Okay, so that sorts the list itself. Ordered years is equal to int of I for I in average returns dot keys. And then for year in, nice, now we're getting somewhere. So ordered years equals that, and then we're just gonna do ordered years dot sort, and then for year in ordered years, year average returns of year. Oh, no way. It's not because it wasn't sorted, it's because it's trying to plot a dictionary. But that's okay. So for year in int of for year in ordered years, then we could say this, we actually just want to get I for I. Because if we get an integer, then we can't get it in average returns. Actually, I take that back. We're going to convert it to an integer, and then we're going to sort it, and then we're going to convert it back into a string. String of I for I in ordered years. And then for year in ordered years, AR for average returns, AR dot append, average underscore returns of year. And then we want to, our bar plot, years to look back. So instead of this, it should just be ordered years and then AR. Okay, now let's see if that gives us what we want. So continue to get out of the debugger, and then let's run the analysis again. Nice. So the years are in order and the performance over time plot looks good. Um, Select axes. Testing number of training years. I want to know how to change that. Um, okay. So I guess we could say get training years plot, and then we're going to pass in a plot title, which is a string, and it defaults to none. And then here we're going to say if plot title is not equal to none, fig.subtitle plot title. Um, Obviously, it should just be plot title. Okay. Um, then we show it. So it defaults to none, but when we call it down here, we want to say that the title is triangle method. Okay. And then let's plot real quick. And then we'll be done with the plotting and we'll be able to get this plot for the other methods. So we've got that. And let's put it in the PowerPoint. We could take out this stuff because those don't look good. Nice. And there we go. Okay. So that's the results for the triangle method. Now let's go do the same thing for the rectangle method or the hybrid method. So optimization data slash training years test slash hybrid slash hybrid. Okay, now this one is the hybrid method. Okay, and let's go run it. Okay, the hybrid method I guess did very poorly. Um, wow. Okay. All right, now let's go put that in. So the hybrid method performs poorly. Triangle method did pretty well. Okay, now back to the PowerPoint. Let's put that in. All right, so now we've got plotting automated for when we test the method. Um, we did not finish though the other things we were going to work on. So the other things to work on were, oh, we were going to add new optimization techniques. So we didn't get around to adding new optimization techniques this morning, but we can do that later. Didn't generalize that. Take bounds definition out of optimized line location and put it into the regions dictionary. All right, so we've automated the plotting. And then for this analysis, we finished it for the hybrid method as well. Um, and then here I'm going to put run analyses before next live stream so that when I start the next live stream, I'll have all the analyses done. We can discuss them and then I'll get right into coding. Okay, so those are the next two. Um, we've random box region. Um, this I'll put in done because we didn't do random box, but we did random circle. Didn't do random box, but did random circle, which is simpler. Okay. So we have things to work on for next time. We've got our plots and stuff. Then this will be the end of this stream. Thanks for watching, and I'll continue the work in another stream.